Hey everybody, this is Polar Unit Video 9, and we're going to be talking about raising complex numbers to a power, so applying exponents, and this is going to lead us to a theorem from de Moivre. Alright, so we're going to recall multiplication from our previous video and the previous section that we were working on. So I'm going to take this and I'm going to be multiplying something by itself. In other words, I am squaring this number. So keeping that in mind as we work through this problem, if I have r plus r, or r times r, I could write that simpler as r squared. And I'm supposed to be adding these theta values, but since they're the same angle, I'm going to then just multiply it by 2. So this gives me cosine of 2 theta plus I sine of 2 theta. So I'm going to write that a little bit shorter. I'm going to say that r cosine of theta plus I sine of theta to the power of 2 will equal r squared times cosine 2 theta plus I sine of 2 theta. To write that in our r cis, or the shorthand, if I had r cis theta squared, I would have r squared cis 2 theta. These are exactly the same thing. I'm just writing it in shorthand here in the second line. Let's try it when I'm multiplying it by itself 3 times or cubing. So if I have r times r times r, I get r cubed. And then I would have cosine of theta plus theta plus theta, or 3 theta, plus I sine of 3 theta. So if I'm taking an r cosine of theta plus I sine of theta and raising it to the third power, I get r cubed cosine of 3 theta plus I sine of 3 theta. In shorthand, I would have r cis of theta cubed, and that would equal r cubed cis of 3 theta. So what if I applied any exponent? Suppose the exponent n. Okay, it looks to me as though when I'm applying the cube, here the exponent, I cube the r value and I multiply my theta by the number that I've got. So let's start with our longhand, r cosine of theta plus I sine of theta to the nth power will equal r to the nth cosine of n theta plus I sine of n theta. Here I'm multiplying. Let's write it in shorthand. R cis of theta to the nth power will equal r to the nth cis n theta. So the n gets applied, the exponent gets applied in two different places. To the r value, we're raising it to that power. For the theta value, we multiply it by that. Let's try a couple. So for example number 1, I'm going to take 3 to the third power cosine of 3 times 30 degrees plus I sine 3 times 30 degrees. So this is going to simplify. 3 cubed, be careful, it's not 9, it's 3 times 3 times 3, or 27. I'm going to turn this into shorthand because I'm running out of room as I write. Cis 3 times 30, 90 degrees. This is my answer. Okay, now I've got one that's written in rectangular form. Problem with that is I would have to write this out 5 times to multiply it. And then I'd have a whole bunch of distribution to take care of. So rather than do that, let's go ahead and convert it to polar form, and then we'll have no problem doing this. So I'm going to find my r value first by taking the square root of 3 squared plus 1, not I, squared, which is the square root of 4, or 2. And then I'm looking for my theta value, which is a tan inverse of 1 over the square root of 3, which will be our 30-degree angle. This is in the first quadrant because they're both positive. So I'm going to write this as 2 cis 30 to the fifth power, and now I will apply my fifth power, my exponent. Okay, so this gives me, sorry about that, this gives me 2 to the fifth cis 5 times 30 degrees, or 32 cis 150 degrees. All right, next up, we've got 3 cis 100 to the fourth power. So I'm going to first raise this to the fourth power, and then I'm going to have cis of 400. So I'm going to do two things. I'm going to reduce or simplify my 3 to the fourth power to be 81. And then I'm going to have to remember to subtract 360 degrees because I want to keep this within our one rotation of the circle. And I'm looking for the coterminal angle, so it's going to be 40 degrees. Sorry about all the noises. Here we go. So this is 81 cis 40 degrees. Okay, I want you to try these two on your own, remembering that this first one here you get to go straight into, and the second one you're going to have to convert this to polar form first. So the first thing you want to do is polar form. And the second thing you're going to do is to apply de Moivre's theorem. And this de Moivre's theorem is that exponent rule. So apply de Moivre's theorem. Don't forget to check for which quadrant. It's very important in getting the right angle. All right, good job. Okay, so simply we've got our de Moivre's theorem to be r cis theta to the power of n gives us r to the n cis n theta. And that's the shorthand. It's just applying the exponents rather than adding all of your thetas and multiplying out all of the r's. This only works if you're using exponents.